In this video, we're going to look at a real-world example of a function. So we're going to go a little bit beyond the abstract examples that we looked at in the last video. And hopefully this will help you to understand that functions are in fact all around us. And to help build that understanding of what a function is, in fact the definition of a function, just that little bit further. Let's say we had 7 people. Oops, I'll just drop that out. Let's say you had 7 people at a school, and these 7 people are associated with 3 different homerooms or pastoral care classes. So it was usually where you get your name marked off in the morning. So the first 3 people are associated with homeroom number 1. The 4th person happens to be associated with homeroom number 2. And the last 3 people surveyed happen to be associated with homeroom number 3. Now this is clearly an example of a function. Every person is associated with no more than 1 homeroom. Now it's possible to have a homeroom that's associated with multiple people, and that makes perfect sense. You could have, for example, a homeroom of 25 students, or a pastoral care class of 25 students. But each student is associated with only 1 homeroom. It doesn't make sense for one student to be simultaneously associated with 2 different homerooms. This is a particular example where there's probably no relevance, or there's no, it's in fact may in fact be impossible for that to happen. I mean, we don't know, or it's not even realistic. Now we could, for example, have an 8th person. So let's say we introduce person number 8. We ask this person, what homeroom are you associated with? I'm associated with homeroom number, I don't know, 5. It doesn't happen to be in this set, so we can't draw an arrow, but this is still a function. Every person is associated with no more than 1 homeroom. Now, obviously at a school, generally every student is associated with 1 homeroom, and that's usually the case. Let's look at sort of a twist to this. What about this? So I didn't draw the circles around these. So let's say we took another sort of 4 random people, and we asked them, which homeroom are you associated with? Person 1 said, I'm associated with homeroom, I'm in homeroom 1. Now person 2 said, I'm in homeroom 1, and then later said, I'm also in homeroom 2. Person 3 said, well, I'm in homeroom 2, and person 4 said, I'm in homeroom 2 as well. Is this an example of a function? Now, I think, well, no, can't be, because this person number 2, has stated that they are simultaneously associated with homeroom 1 and homeroom number 2. And while, look, there may be a situation where this may be possible, I don't know, I'm just saying, this breaks the rule of a function, or the definition of what makes a function, or what creates a function, that every element in the independent set can associate with no more than 1 element in the dependent set. So this one clearly is not a function. It's a relation of sorts, but it's not a function. Can you think of other situations, for example, and I'll just go back to this diagram here, that you could think of in your daily life that in fact mirror or represent a type of function? So you might think of, for example, you're a member of a sporting team, for example. So, is that possible to be simultaneously associated with multiple sporting teams? You might think, yes, that is in fact possible. So there are situations and relations where it is possible to be associated with more than one thing. That doesn't mean it's a bad thing. It's just to say that it is not the definition of a function, though. It's something else, and of course, there are situations and a large number of situations like that. But think of a situation that is clearly a function. In other words, 1 element in the independent set associates with no more than 1 element in the dependent set. Thanks for watching.